Okay, today we're going to talk about a failure mode and effects analysis. I've got a little Excel template here that's going to help us to carry out an FMEA. That's a lot of times you'll hear the acronym for failure mode and effects analysis, FMEA. All an FMEA is a structured and organized way to identify what can go wrong in a process. After we identify what can go wrong, we're going to give some scores. That's basically going to let us prioritize all these different potential failures. So this is a technique that's going to help you to identify what might go wrong, prioritize which ones have a higher probability of actually happening and how bad they are, and going to kind of lead you to some steps where you can take some steps to either prevent those failures from ever happening, or if they do happen, to minimize their impact. So looking at this template, first thing we're going to do is fill out the process name. So we need to define what it is that we're looking at. And then we just start brainstorming. And brainstorming consists of what are the things that could go wrong with our process. And that's in this first column, the failure mode. It's what can go wrong. Next, we're going to fill out a cause of the failure. So why does it go wrong? Why did that happen? Column C here, we're going to fill out what happens when it goes wrong. So what's the effect of the failure? Is there a loss of life? Is there product damage? Is customers aren't satisfied? Is there a financial impact? Then we start getting to the scoring. So for each of these failures that might happen, we're going to give a couple of scores. And the first score is the likelihood. And we'll see up here, the likelihood is what's the chance or the probability that it'll go wrong. And this isn't necessarily a statistical probability. We're just trying to give some relative scores, with a 1 score being that there's a very low chance that this will actually happen, that this failure will materialize. A 5 score means there's a really high chance that this is probably going to happen. Then the next thing we're going to score is the detectability. Is the failure apparent? In other words, when the failure happens, do you know that it happens right away? Or is it something that can fail and you don't realize that it's happened until maybe the customer gets hold of it? 1 means it's easily and quickly detected. So immediately when the failure happens, you know that it happened. You can do something about it right then. A 5 means that it's very difficult to detect, and it may not be detected until it's in the customer's hands. The last scoring criteria here is the severity. So how severe are the effects? 1 is some kind of minor damage. 5 is severe damage, and that damage might be to a person. You think about a 5 in severity might be a product that a failure would cause a loss of life or some kind of severe accident. Maybe a 1 in terms of damage, might be some customer complaints, maybe where you don't lose customers necessarily. Then we're going to give it a risk priority number. The risk priority number, you can see we have a formula inserted here, is just the likelihood times the detectability times the severity multiplied together. And that's going to give us an RPN, or a risk priority number. And let's take a look at one of these that's been filled out. This was a failure mode effects analysis, or at least part of one that was done for a process of outsourcing a product. So let's see what kind of failure modes there were. One possible failure was that there could be increased cost. And why? What was the cause of that increased cost? It was unforeseen management costs. So this team thought that one of the potential failures of outsourcing a product was that it was going to cost more than what they thought it was going to cost. And why was that going to happen? It might happen because it was going to cost more to manage the outsourcing process. So that's that unforeseen management cost. The effect was that the product cost increases. The savings weren't realized, so this outsourced product had been justified based on some savings, and if costs went up, then maybe the savings aren't there. So here's where they start scoring. Likelihood. What's the chance that that was going to happen? And you see they give it a likelihood of 4, which means that group thought that there was a pretty good chance that there was going to be some unforeseen management cost. Detectability was a 4. It means it was hard to detect until it already happened. It's unforeseen, so almost by definition, the detectability would be high. You don't really know what's happening until it's almost too late. Severity was a 3. We're not talking about any loss of life here. It's not that your whole business goes bankrupt. It's that some product that was outsourced doesn't realize the savings. So, kind of middle of the road in terms of severity. And then again, we multiply, for the risk priority number, we multiply the likelihood times the detectability times the severity. And then there was another failure mode. They said there could be a delayed in delivery. So they've outsourced this product. They're expecting delivery at a certain time. And their idea was that the cause of the failure may be that there just may be a delay in the manufacturing process. This was a product that was outsourced outside of the country, so they had some concerns about schedule. The effect of the failure, obviously the lead time would be extended. You'd have late deliveries. Likelihood was a 3, so a little less likely than the unforeseen management costs. The detectability was a 3, so they felt like they would be able to see this happening, delay in manufacturing process. They would have a little better chance to know what was happening right when the delay was going to happen. Severity was about the same, was a 3. Again, multiply the likelihood, detectability, and severity together to get a risk priority number. And this is actually only a portion of the form that the team filled out. So there's only 3 failure modes listed here. They had many more than this, but I just picked out a couple, for example. They talked about there could be a quality defect. And what was the cause of the failure? They thought maybe just some kind of minor cosmetic defect with the product. And the effect of that would be poor customer satisfaction. Likelihood, again, likelihood was pretty high. They were really concerned that they had pretty much nailed down major requirements and specifications for the product, but they were concerned about some of the minor cosmetic blemishes that might be there. Detectability was a 2, so that says it was easily detected, so they would know that there was a cosmetic defect. And the severity was a 2, so again we talked about a minor cosmetic defect, so it's not a high in terms of severity. Multiply our likelihood, detectability, and severity together to get us a risk priority number of 16. When you fill these out initially, you're not going to know your risk priority number, so you're going to end up with this chart filled out, and your risk priority numbers are probably not going to be in descending order, so you want to sort this in descending order. Highest risk priority number comes first, lowest risk priority number comes at the bottom of the chart. We want to put most of our efforts on the failure modes that have the highest risk priority number. And then what we would do next is fill out some recommended actions. What is it that this team can do to either prevent unforeseen management costs from ever happening, or if they do happen, to minimize the severity of it happening. So you're going to fill out your recommended actions, and then you're going to rescore likelihood, detectability, and severity. And if your recommended actions have any impact at all, you're going to have a lower risk priority number. You would do that for each of the failure modes, and then after you rescore and have new risk priority numbers, you're going to resort and basically kind of see what you have left and how much risk there is. So that's a failure mode and effects analysis. A real simple tool, but a great tool for helping you organize and assess upcoming risks.